Name is Lenton. I'm a second year computer science student at UoL. I started my course back in 2021. I'm taking it very slow. So if you see me after another 1 or 2 years still in the UoL Slack channel, don't judge me. And I also work with a company called Akamai Technologies. I started my career um, as a network administrator. That's how I got exposed to the computer networks. Um, Overall, I possess 15 years of experience in the tech industry. That's about me. About the series, at GDSC, we have been discussing about ways to help people understand more about the computer networks. Essentially, what happens when you try to access something in the internet in the background, right? Might sound very simple, like, hey, what's the big deal? I access a website and that's it, right? But there's a lot happens in the background. So we are hoping to help you guys know more about it. That's the goal of the series. When I say series, we are planning more trainings in the series as a continuation. So now about the IP addressing itself, why IP addressing? I'm sure if you have tried to know more about networking, they usually start with different type of networks um, and different type of layer one devices like hub, bridge, like topologies. These are the usual things you will see, OSI layers, right? We skipped all that because our intention is to introduce you to the practical aspects of networking. Because if you ever end up working in a computer networking domain, like a network administrator, you're not going to troubleshoot an OSI layer. You should know the theory, no doubt about it, but you would see more of like computers, IP addresses, right? Why is it not connecting? Is the IP address right? These are the things you will see. That's where we decided we will start with something like this, IP addressing, right? Now, um, I want the session to be really interactive. So if you have any questions, feel free to stop me in between. Now, that being said, if it is taking too much time, we might keep some questions towards the end. And if the time is still not enough, we might not answer the questions during the session. But feel free to post it in the GDSC UOL channel or ping me unicast, and we will try to answer those. Okay? And to keep a track of time, we have GDSC members here. Rita, if you don't mind, help us with that. Uh, the target was to complete the session in 75 minutes, maximum 90 minutes, because we have some practical exercises. So let's see how it goes. Okay. All right, let's get started. Enough talk. Before we get to IP addressing, right? What is a computer network? All right. Do anybody want to try explaining what is a computer network?
Connected computers?
Exactly. A computer network is, like Angela mentioned, is a collection of computers which are interconnected. Why should we connect these computers? What is the benefit? With that connectivity, computers can communicate each other. That's the benefit of network. And internet is a network. It's a network of computers. It's not just computers. We have mobiles, IoT devices, right? A whole bunch of devices in internet. So now we know what is a network, right? Now, what is an IP address? In a specific network, to identify a computer or a IoT device, it needs an identifier, and that identifier is IP address. Okay, imagine a street where there are many houses, right? To know the to know the exact house, there is an identifier like a house number, right? You can say that's an IP address for that's an IP address in a computer network. Okay. Now, Should it be unique? The computer, I mean, the IP address, it should be. It's just like a postal address, right? Imagine two houses having the same address. A mail meant for one house can go to the other. The same can happen in a computer network. If there are two computers with the same IP address, data meant for one computer could go to other computer. Hence, IP address has to be unique in a network. So now we know what is an IP address. Why do we need it? Now, let me share my screen and show you how it looks like. I have my notes on the side. So if I look at the side, it means I am looking at my notes. All right, sharing screen. Oops. Are you guys able to see the screen without any issues? Yes, I could see like a whole bunch of mini screens. Checking. Can you guys see my
Um,
screen? Okay.
yeah, it's good. It's only when you navigate to the Bevy tab that we
Okay.
see, you know, the multiple windows.
Okay.
But
Okay.
otherwise, everything else is good.
It's good. Okay. Cool. All right. So I have the agenda listed out here. So anytime you feel like checking where we are, let me share my URL with you. If you wanna open it in your computer, you can do that. Baby. Oops. Oh, okay. When I come to the baby, this is what happens. Chat. Okay. So this is the URL to the whiteboard what I'm using. You may open it or you could just follow along. All right. So in here, I have the agenda listed out in a sticky note. So we already discussed about IP address. We are talking about what does it look like, right? Here's an IP address, right? So 192.168.1.1. This is an IP address. Okay. Oops. I see somebody is waving. Kylie, is that you? You trying to say something? Or it's your brother? Okay, I was saying. Okay, cool. Uh, okay, so this is an IP address, 192.168.1.1. Now, an IP address is essentially, as you see, it's 4 digits separated by a decimal point. Okay. Now, this is for easier understanding for humans. For computers, it's always represented in binary. So the same IP address, 192.168.1.1, when converted to binary, would look like this. Uh, I'm sure most of you might know about binary, but essentially it's just a different numbering system. For example, 192 in decimal, if I convert to binary, I would see something like this. And that's what I have mentioned here in the binary section. So in reality or in computer language, IP address in binary has octets. Can someone tell me what is an octet? If you don't know, it's cool. If you know, go ahead. What's an octet in binary? A hint, you are looking at it.
Set of 8 bits.
Exactly. It's basically a digit with 8 bits. That's an octet, right? Now, to remember it easily, you could think of a spider. An octet the spider. An octet has 8 bits, a spider has 8 legs. So in a IP address, there are 4 octets, 4 spiders, and 32 bits. What's that 32? Each octet has 8, 4 into 8, 32 bits. Now we are talking about IPv, IP version 4 address. So in IPv4, we have 32 bits. Uh, Recently, IPv6 has been becoming more and more popular because we needed more and more IP addresses. The difference is IPv6 has 128 bits in it. For ease of understanding concepts, we would be using IPv4 in this session. Okay, coming back to the IP address. So IP address has 4 octets, 32 bits. Now, an IP address is split to two parts. One is a network portion and another is a host portion. What do I mean by that? Let's go back to the postal address concept what I was referring. Every house is in a street, right? The street has a name or a number, right? There are many houses in that street, and that street number is common to all those houses. But the house number is unique to each of that house. Similarly, in an IP address, the network part is common to all the devices in a network. The host part would be unique for each of the devices in the network. That's the network and host portion of an IP address. Any questions so far? We good? Okay, I'm gonna assume. Yeah, go ahead.
Yeah, I was gonna say that every device. You said that every, every computer needs its own IP address because it's something that's private to the computer. So I'm assuming every device has an IP address, a different IP address, right? Like
Yep.
mobile computers and all that. So do like those really vintage mobile phones, right? Flip phones and stuff that can't connect to the internet. Those don't have IP addresses, or do they?
No, they don't.
Okay.
Yeah, any device without a networking capability won't have an IP address. It will have a different address called MAC address. That's in the next session.
Ah, okay, okay. Nice teaser, I guess. Got it.
Cool. Going on. So, if no questions, let's move forward. So I said IP version 4 has 32 bits. Why 32 bits? Why can't it be lesser or why can't it be lesser? Makes life easier, right? So, if we go back to the history, right? Internet was when it started was known as ARPANET. Now, ARPANET had 4 computers in it. That time they didn't need so many IP addresses, just 4 IP addresses, right? So they started with 1 octet. That would mean 8 bits are used for addressing purpose. No network portion, no host part, nothing, right? Now, how would it look like? I said 1 octet, right? So 1 octet, 0, 0, 0, 0, 0, 0. So 8 zeros. 8 octets, right? Now, this is the smallest number I can come up with, 8 bits. What is the highest number I can come up with? 8 bits. This is binary, okay? Okay, saying 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Excellent, valid point. Now, if we convert this to decimal, what do we get? 255, right? So this would mean I can give address to 255 devices with 1 octet. But we have way more, right? Over the period though they started with 4 computers, it got added up more and more and more, right? Now, they say that back in 2015, there were around 15 billion IoT devices, right? but we still survived with IPv4 at that time. IPv6 became common more recently. How did we achieve that? We'll get to that at a later stage. But coming back to this 4 octet theory, essentially, when we needed more and more IP addresses, they increased the number of octets so that they could have more IP addresses. Now, how can they have more IP addresses? By adding more octets. Let's see. Okay. So, all right. Let's say that 0.0.0.0. Okay. 4 octets. The largest would be 255.255.255.255. Right. Now the next one would be 0.0.0.1, and it'll go till 0.0.0.255. Okay. Now the next would be, I'm sorry, let's skip to that later stage. Okay. The next would be 0.0.0.1.0. So I can continue like this, and then the next octet would come into play, 1.0.0. So essentially, the end would be 255.255.255.255. Now, to get the number of available IP address in this network, I could do two things. One, I could just multiply with 255, 255, 255. That'll give me roughly around 4 billion hosts, right? Another shortcut to get the number of hosts is raising, I mean, like 2 raised to n, where n is the number of bits in an IP address, basically the host portion bits. So 4 billion, right? Now with this 4 billion, we still survived with uh, like like this 15 billion devices I was saying, right? We still survived with 4 billion IP address. How did that happen, right? So one thing what we did is we introduced something called classes, different classes of IP addresses. Okay. Now, what are those classes? Basically, there were 5 classes of IP address: class A, B, C, D, and E. Now, class A is 1 to 126, class B is 128 to 191, C and 190 to 23. We won't discuss a lot about class D and E. Class E was created for research purpose. Class D was created for multicast. The multicast we will discuss when we talk about special IP addresses later. For now, the focus is on class A, B, and C. Okay, when I say class A 1 to 126, what I mean by that is one dot zero dot zero dot zero to 126 dot 255 dot 255 dot 255. This is class A. Okay. What is class B? I hope you got it. Sorry, what about one? Hey, excellent, fine. That was my next question. Did you see that 127 is missing here? It's because 127 is used for a purpose called loop back. Again, I have a section meant for special IP addresses. We will talk about loop back IP address in that section. But excellent find. You have attention to detail. Cool. So that's class A, class B 122, 128 to 191. See here. Okay. So these are different classes of IP address. Now I have also written something afterwards for class A 255.0.0.0.0. That's a subnet mask. Now, what is a subnet mask? Why do we need it? So I was mentioning earlier, an IP address has two portion. One is a network portion, the second is a host portion. So whenever you see a subnet mask, look at the part where you have 255. It's basically filled with ones, which represents the network portion of the IP address. So in this example, 1 is the network portion, 000 is the host portion. Hope that's clear. Any confusion here? Okay. Oh, I see the fire. Thank you. Okay. So that's different classes of IP address and subnet mask. Okay. Let's move ahead. And I was telling earlier, the IP address has to be unique. It can't be duplicated, right? Now, in this setup, like with the IP addresses spread across, I can assign an IP address or configure an IP address in my computer. And I have no clue if you would configure that too. We don't know each other. And I have no clue what IP address you are using, right? That could create a problem, right? So yes, this started happening, and that's when there was a centralized organization called IANA was introduced. IANA, or Internet Assigned Number Authority. I think that's the full form. Let's check. IANA, Internet Assigned Numbers Authority, IANA. IANA is responsible to control the IP address distribution centrally. And they do that by giving IP address block to something called RIR. It's Regional Internet Registry. Essentially, each continent has an RIR. Okay, so I think some continents are combined, like Asia and Australia has the same RIR. So RIR is responsible to distribute the IP addresses to ISPs, and ISPs further to sub ISPs, and that chain continues. Okay, so IANA along with RIR ensures IP addresses are not duplicated when distributed. Okay, now let's go ahead a bit more and talk about subnetting. So far, what have we covered? We covered what's an IP address, what does it look like. We talked about history. We talked about IANA and RIR. We talked about different classes and subnet mask. Now we will talk about subnetting. What is subnetting? Let me clear this. Oops. Oh no. I'm using a digital whiteboard. It's not very much used to it, hence the slow movements. Sorry about that. All right. Subnetting, right? Now, what is subnetting? Why do we need it? How do we do it? This is what we will cover in subnetting. So let's say that you are working in an organization. Okay. Um, Hold on a second. I actually got some questions for you to answer to familiarize with different classes. If you could open, you know what? Let's just go with this. Let's just try this. Okay, let's go with this question first and see if you got the concept of different classes. Identify which class this IP address belongs to. Which class this IP address belongs to? Hey, by the way, I can't see chat, so you gotta either talk or just write it here. Should I share the URL? I guess that would be easier for you to type it if you don't want to talk. I just saw someone mentioning class A for this, right? Class A. Yeah, good point. It starts with one. One is like 1 to 126 is class A, hence this is class A. Which class this would fall into? Yeah, feel free to write. Go ahead.
I think we don't have edit access, but this is class B. So
Oh, damn. Okay. Sorry. Share says can edit. I should copy the link, right?
yeah, I think you shared it correctly, but
Still doesn't let you edit.
maybe I'll reopen it. Maybe it's a me problem.
Oh, I see someone else mentioning view only. Oh, Alexandro. Oh, yeah. Okay. If you can tell me how should I do it, I can do it. Like, is there anything else? It says anyone edit. Yeah, edit. I don't know.
I think it's okay. Maybe if people type in chat, I'll just read it out.
Yeah,
Or
sure. Yeah, let me know. Okay. So this is class B. Good. Yeah, that is class B. Kylie is magically typing. So yeah,
yeah, I
class
don't know
B.
how she
Yeah.
does that.
Yeah. Class A. Yeah. Good. Yeah. And this would be.
Class. Hold on.
Oh yeah.
C. Yeah, there we go.
Yeah. Nice. Cool. Let's look at one more question. Let's see if you are remembering that part what I mentioned about subnet mask. Okay. Basically, identify the network portion of each of these IP addresses. I'm gonna quickly check the chat. Okay, 9. Yeah, exactly. So 9 is the right answer. So the first octet is represented by like 255. Hence, the first octet is the network portion. I see 103. Yeah, that's right answer again. Nice work, Kylie. The first octet 255 is representing the network portion, hence 103. Yeah, that's right. 222. Yeah. Okay. Yeah. You got it, Jarvis. You got it. So yeah, the first three octets are representing the network portion, hence that. The fourth one is okay. Yep, got it, Jarvis. 10 dot 13 dot. Yep, that's the network portion for this IP address. Okay, hopefully you got the concept of classes and the subnet mask by now. If you have any question, feel free to ask in the chat or in the call. Otherwise, we will move forward. Hey, Ankit, I see your answer, class AACC. Okay, is that the right ones? Oh, it's ABAC. Yeah, Ankit, but nice try. Good try. All right. Okay, let's get to the subnetting part now. Uh, okay, we're talking about, say that you are the network administrator for an organization. Okay, there are different departments: finance, HR, support. Right now, in some scenarios, you might want to configure in a way the computers in the finance network shouldn't communicate with computers in the sales. Right, you want to restrict that. There are many ways to do that, but you can actually do that with subnetting too. How? By splitting a network into smaller networks. Let me show you what I mean by that. So here is an IP address. So that 192.168.1.1 is an IP address. Here is the subnet. This is the default subnet. Okay. Now, based on this IP address and subnet, how many computers can be part of this network? Trick question. Oh, yeah, it was not so tricky, I guess. Yeah, exactly. 255 computers can be part of the network because these three octets represent the network, and then there is one octet which represents the host, and the highest number you can come up with, that is 255, hence 255 computers. Okay. Now, the IP addresses in this network would look like 192.168.1.12, 192.168.1.255. Okay. But if you assign, this is the smallest network we know so far, right? So there are like 255 IP address. How would we split this further to a smaller network? Essentially, by so this is the binary representation of the subnet mask. So as I was saying, at this point, this is the portion representing the network, this to the host. Out of this, I will borrow few more bits to the network portion. Okay, and I will make something like this: 1, 2, 3, 4, 5, 6. Right, so the 6 bits are not available for the host addresses. Now if I convert this number, what will I get? Let's see. 252. Okay, so 250. The subnet mask is updated. Now there are 2 bits for the host, right? Now what are the available binary numbers which you can come up with? The 00011011, right? 4 IP addresses is all we have now in this network. Bit confusing, I guess, right? Now how did we get this four in here? There are multiple ways. One, what I just did, right? 2 bits for hosts. So it's 00011011. That's all you can create with binary numbers. Second thing, what you can do is you could simply reduce 252 from 256. That tells you how many IP addresses are available in this network. Now, with this, what is happening is we are splitting the 255 IP addresses into blocks of 4 IP addresses. Now each block is a smaller network. So here this would be 192.168.1.0, 92.168.1.1, 2.168.1.2.168.1.3. We only have 4 IP addresses in this network. Clear so far? Any questions? I know this part can be a bit tricky. If you have any questions, feel free to unmute yourself or post it in the chat. Okay. You know what? We will look at some quiz questions that might give a bit more clearer picture. But before that, let's see if let's look at another example. Would that help? Or you guys already got this concept? Oh, I see you typing something. I couldn't read that question, Kylie, completely. If you could type it out again. It's not 192 1.25022. Uh, not really. So when we talked about 252, right, that's the subnet mask we are talking about, right? Subnet mask is just to tell us which part of this IP address represents the network and which part the host. So essentially, we are creating a subnetwork in which this IP address belongs to. Okay, good. Yeah, yeah, I could see how it could be confusing. So yeah, so what happens is our earlier network was this, right? 192. This was our network before we did the subnetting. Now after subnetting, what happens is the IP, this whole thing will be split into blocks of 4. Now the next block is 192.168.1.4. It'll go till 192.168.1.8. So in this blocks, now how this is becoming a subnetwork? Basically, in this big network, 1.2 can communicate with 2.2 1.255. Any IP addresses can communicate each other, but once we do the subnetting, only these 4 IP addresses can communicate each other. This can't communicate with this guys in here. That's what we are doing by subnetting, splitting a large network into multiple smaller network. Hopefully you guys got the concept. Now, okay, great. I see the fire. Nice. Okay, cool. Now this at a later stage, right? It's a bit of a pain to keep representing IP address and the subnet mask, and that's how the concept of CIDR notation came in. So essentially, CIDR notation would look like something like this: 1.1.24. What this means is 24 bits represents the network portion of this IP address, right? That's again going back to our initial subnet mask 255.255.0, right? Now in this example, after we did the subnet, it's more than 24, 8, 16, 24, another 6 from here. So that would make it like 92.168.1.1/30, right? So this you will see interchangeably. It could be a subnet mask or it could be a CIDR notation. Both means the same thing: number of bits representing the network portion and the number of bits representing the host portion. That's all it is. All right. I would like to mention one more thing in here. After subnetting, right, you see 4 IP addresses in here in this block. Now, can we use all 4 IP addresses in devices? No, we can't. Once for every network, Remember, I was mentioning about a network address. Oh, no, I didn't. I just mentioned the network portion. So every network has an identifying IP address, which is always the first IP address in that network. In this network, it is 1.0. In this network, it is 1.4. Okay. Now, the last IP address is known as broadcast IP address. What is a broadcast IP address? If a computer having this IP address, if it wants to send a data packet to all the devices in that network, it will simply send to this. That packet will reach, or that data packet will reach all devices in that network. That's the purpose of a broadcast IP address. So whenever you do subnetting, you will see, once you get the range of IP address, know that the first IP address and the last IP address is not usable. Okay, it's assigned to network and the broadcast IP addresses. Okay, time for an exercise. All right. Two. Okay, let's get to the third one. Identify the CIDR notation for below IP addresses. What would that be? 24. Right answer. Essentially 8 plus 8, 16 plus 8, 24. 24 bits represent the network portion. Yep, got it. 16. 8 plus 8, 16. Yeah, there you go. I like the way how you put the proof as well, Jarvis. All right. What if it is the other way? I think this question is very silly, but let me change it up. I think I did it in a hurry. Maybe I could try something else. 10 dot 0 dot 0 dot 2 slash 3. What is the answer for this? Yep, there you go. You got it, right? Basically, it's the number of bits which are used for the network portion. So, right. That would come to something like this. 224. 224.0.0.0. That would be the subnet mask for the CIDR notation. All right, cool. Let's look at one more question. It's a bit tricky one, but I'm sure you will figure out pretty soon. Now, here is a network. Okay. I have a network here. It's a 0.0 slash 24 network, 1.0 slash 24 network. Now, I haven't mentioned it earlier. To enable communication between two different networks, we use a layer 3 device called router. I'm sure you have heard this term, home router, right? What ISPs give you. It's essentially does this. It enables communication between two different networks. So if you see here, right, this network is a 0.0 network. This is a 1.0 network. And between the routers, we have 2.0 network. Okay. This will enable these links to communicate. This will ensure whatever devices in here can communicate each other. But in this case, 0.4, which is this computer, is not able to communicate with 1.7. Why do you think that is? If you are familiar with the routing concepts and all, don't think too much. We are not going in that line. Is limited. The middle link is limited. Could you elaborate a bit more? I think you got it, but just so that everybody gets it. Yeah, exactly. So let me explain what Kylie is trying to say. So in the middle, this network has 172.168.2.0.30. Now slash 30 would mean we have 111, essentially 255.255.255 dot like 6 more bits. That would be 252, I guess. 254. 2, 3, 4, 5, 6, 7. It's wrong. 2 bits, right? 252. Right? So the subnet mask would be 2. Oh, oops. Oops. I just lost my ability to write. What happened? I'm gonna reload the page. Bear with me, please. Okay. Okay, I got my writing ability back. All right, 252. So as I was saying earlier, right, to get the number of usable IP addresses in this range, you could just reduce 252 from 256 and you will get 4. And in that 4, you already lost one IP address as network and one IP address as broadcast. So that makes it 172.168.2.1, 172.168.2.2. This is all available in the network. But if you see here, the IP address used is 2.20, which won't work. Hopefully you guys got it. A fire emoji would mean that you guys got it. Okay, cool, you got it. So yeah, so it's a subnetting error, right? You have /30, which makes just 2 IPs available. Now let me ask you this: how can I make it work? What can I do? Didn't see that coming. Yeah.
Yeah, not at all.
IP addresses used to be within the reach. Sure, I got that, right? What number should I use here? What should I use? 17. Okay, 168. Yeah, 168.2.12. Got it. The IP address range. Cool. Now, how can I represent that with a subnet mask or a CIDR notation? You're on the right path, Kylie. Your answers are right. Now, this is the final bit of it. What subnet mask or CIDR notation can I use? I see. Yeah, sure. So we mentioned earlier, right? To if we use 8 bits completely, we have 255 hosts, right? Now, if we use just 2 bits, we have 4 hosts. Now, if we use 3 bits, how many hosts we can come up with? We'll have 0 dot 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1, right? 3 4 5 6 7 8, 8 hosts available. Out of that, 2 went for broadcast and network. It's still not enough because it's 1 and 20, so we need more than that, right? So how about 4 bits? What is the highest number you can come up with? 4 bits. 1 1 1, right? Let's try. Let's see this. uh 15, still not enough, right? 31. With 5 bits, we were able to get 31 hosts. Out of that, 2 spent for network and broadcast, so 29 IP addresses are available, right? That means 5 bits of the last portion should be the subnet mask 255 dot 255 dot 255 slash 28, right? Okay. I think would it I think that would do. Even my brain isn't working. We said 5 ones, all right? 5 ones, 0 0 0, convert that 248. Yeah, 248. 248. So 5, 24, 29. It should be 29, Jarvis. We could actually confirm that in here. Okay. Let's see. Class B 172.168.2 dot, right? 2.1. If we use 248, how many IP addresses we have? Okay, hold on a second. I think I made a mistake here. I think you're right, Jarvis. Let's confirm it. 1 to 14, still not enough. 7. Okay, this is good enough. Our starting IP address would be 2.1. The ending IP address would be 2.30. Right? Now the subnet mask would look like 224. So what is the mistake I made? Oh, it's I made the 5 bits once. It's the other way. I should have done 5 bits, the zeros. Okay, my bad. 224 is essentially slash 27. You guys got the mistake? Like what I made?
Can you do an overview? I feel a bit lost.
Yep, sure, no problem. Okay, so our goal here is to create a block which includes 2.1 and 2.20. This is our goal, right? Now earlier I showed you by subnetting we created blocks of 4. Here we have to create a block which includes these two, right? Now, what is the difference between 1 and 2019, right? Now, we can't create blocks of 19. It's, if I'm not wrong, it's 4, 18, 16, 32. That's the way
Mhm.
how it is done. So
Yeah.
here, that would be 32. We need a block of 32. And if you reduce 32 from 256, 256 to 20, sorry, 32 to 24. All we have done is to include that we chose a block size. By reducing that block size from 256, we choose 224. Now what this 224 means is 224, set the first 3 bits of the subnet mask, I'm sorry, of the last octet to, I said the borrow concept earlier, right? Borrow that to the network part. That will ensure the number of hosts are reduced. Still confusing? I know how I
Uh,
messed up, but again.
no, is this the last bit to ensure the number of hosts are reduced? As
Uh, so when we subnet, right,
Mhm.
we can choose certain block sizes, not as per our choice. What I mean by that is earlier when we said 252, right? So, okay, so these are the, if we choose like a block size of 4, only the last 2 bits of the final octet used for the host, right?
Mhm.
Now, if we use 3 bits of the final octet, that would mean I have 8 IP addresses available. That would also
Right.
mean that'll make it 250, 248.
Ah, okay.
Uh, Basically something like this. I said 3, right? 3 bits 0. The 3 bits, if you do zeros and use this rest for the network address, that would make it 248.
Ah, okay, okay, I get that.
Okay. All right. So to summarize, right, you need to first, when you see this, to make it work, think like this. First, identify the block size. Would it fall in 4 or 8 or 16 or 32? If it is 32, great. Reduce that 32 from 256. What you get in this case, 224, is the final octet of the subnet. Now, 224, when we say, what we are essentially telling is use the first 3 bits of the final octet as network address. Use only the final 5 bits for the host portion. Now with 5 bits for host address, the highest number of hosts you will get is 31.
Yeah.
That summary explains clear?
Yes, yes, I
Okay.
understand now. Thank you
Okay,
so much.
okay. I'm sure if you had that confusion, I'm sure others might also have. Hence, I'm repeating again because this is a key concept, the subnetting. If you don't get it, this session might not really be helpful. Okay. All right. Okay. Cool. I have one more question for you guys. Find out the number of usable IP address, broadcast and network IP address for below network. Now, I want to ask one last time. Hopefully, you guys got it. Do you guys still have any question? We good with the subnetting? Okay. All right. Let's move forward. Thanks for the fire. So find out the number of usable IP address. When I say usable IP address, do consider that broadcast IP and network IP address concept, what I mentioned earlier. So go ahead. Do watch out the subnet mask, okay? You're on the right path, Kylie. There you go. Yeah. Okay. You said 2.14. Now let's validate. Uh, do get familiarized with the IP subnet calculator. This is a handy tool. You should know the concept, but on top of your head, it's hard to come up with the answers always. What's your question? 2.0. All right, 2.0. Now, what's our subnet mask? 240. Before we get to the answer, you have an understanding, right? 256 minus 240. That gives you the number of hosts. So what Kylie posted, that's the math there. So right answer 2.1, first usable IP address 2.14. 2.15, the broadcast IP address. 2.0 is the network IP address. Let's try the last one. I gave a CIDR notation here, but you should be able to figure out the subnet mask with the /24. The second question, by the way. Yeah, that's one. Very well. It's very close, but it's not accurate. And I know why that confusion got created. I gave an IP address here, but here I did put a network address. Now, the thing is, when you see an IP address, right? It can just be an IP address, usable IP address, but the whole block could be different. So in this case, 255.255.255.0 block size in this case is 254. Now you technically start the network with 1.0. That's the network address. 1.1 is the first usable IP address. 2.168.1.255. So the usable IP address would be 1 to 254. Basically 192.168.1.1 to 254. So anytime you see an IP, always you will see IP address with the CIDR notation like this, not like this. Okay, this is how you will see. With the CIDR notation, you should calculate the subnet mask, and with this, you should be able to calculate the block size. Okay, now let's confirm 1.1/24, right? Oops, 92.168.1.1. So class C. We said 20/24. So /24. Calculate. You go. So the network address is 1.0. 1.1 to 1.254 is the usable IP address. This is the broadcast IP address. Okay. Cool. Hope you guys got an understanding of subnetting. All right, let's move on. I was mentioning earlier about the history. Like in 2015, we had around 15 billion devices. How did we survive with IPv4? Yeah, we completed the usable IP address range. Now we are talking about private and public IP address. So yeah, how did we manage with that less number of IP address? So as and when the number of IoT devices increased, right, a new concept got introduced, private IP addresses and public IP addresses. What this means is there is a specific range of IP addresses in each class. So this is what I'm referring to. This is that specific range. This range of IP address can be used by anybody in any way in their network. They can configure with subnetting, like whatever the number of IP addresses, and they can configure however they want. Now the catch is these IP addresses are not routable or usable in the internet. No, in in your home, if you see the IP address configured in your computer, You will see it's part of the private IP address space, right? Now, if private IP address is not usable in the internet, how am I able to access the internet with this? So even with the private addressing, we still use a little bit of public IP address. How that works is all these devices in the home network is connected to a home router. Now the home router has a public IP address. With that, the home router will connect to the internet. So anytime you want to make a communication to the internet, your request will hit the home router. It will change the private IP address to its public IP address, and then it will send that communication to the internet. And when the communication comes back, it'll hit the router. The router will change that public IP address to the private IP address from where it came, and then it'll send back. Now, this process, what I explained, is called as NAT or network address translation. We will discuss that in a later session, but that's how we use NAT to enable internet for all devices in the network. Now the benefit is I don't need an internet routable IP address for each of my device. For tens or hundreds of devices, I just need one public IP address and any of this private IP address. Now I can use a private IP address in my network, even if anybody in the world uses the same IP address in their network, that's okay because this network is isolated, hence it's fine. If we go back to the street address concept or the postal address concept, right? In UK, there might be a street called as Mahatma Gandhi Road or Mahatma Gandhi Street. A street in India can also have the same name, and the houses will share that. But as there is a higher or better identifier called country, it still would go to the right address. Pretty much, it's not, even though it's not exactly the same here, it's something like that. Like whatever private IP address I use in my network, it's isolated here. It is not routable in internet, and anybody else can use that. That's the concept of private and public IP address, which is helping us to survive with IPv4 for 15 billion devices. That's how we survived. Any questions? Good to forward. Good to go ahead. I saw the fire. I'm assuming you got it. If any questions, feel free to stop me. Okay, moving on. Uh, special IP addresses. Okay, what are special IP addresses? We spoke about loopback IP address, multicast, and broadcast. Right. So loopback IP address, the network which starts with 127, is essentially helps you to validate the TCP/IP stack in your computer or the networking ability is fine. How do you do that? Let me quickly show you. Can you guys see my terminal?
Yes.
Cool. So this is a loopback IP address. If I ping that IP address and get a reply, that means the TCP IP stack is working fine in my computer. Quick question. Do you guys know what is ping? Okay. Ping is a tool which utilizes a protocol called ICMP to check the connectivity between two devices. In this case, we are not checking with another device, but it is checking with its own IP address, you can say. So that's how a loopback IP address become useful in the computing world. Now, multicast address. Say that within a network, I would like to stream a video. Now, I don't want to send that to each computer in the network because I would be spamming. What I would do is I would send the stream to a multicast IP address. Whoever wants to watch that can subscribe to that multicast IP address. So if you are a user of VLC Media Player, if you explore the options, you will see that there is an option to connect to an IP address that basically is for this purpose. That's a multicast IP address. Broadcast, I think I did mention, but essentially the broadcast IP address, yeah, exactly, the 1.3, it'll let you send, if you want to send a packet to all the devices in the network, you just send to the broadcast IP. It'll get sent to the entire network. That's broadcast IP addresses, right? Now, IP address configuration, okay? Uh, can I assume that you guys have Cisco Packet Tracer installed? If yes, I would recommend you guys trying this on your own. It's very simple steps. We will just configure an IP address. We will see how it can communicate each other. That's what planning to do.
Yes, I do have it installed.
Okay, cool. In that case, let's configure two computers and see if it is communicating and devices. Okay, if you have the Cisco Packet Tracer open, this is what you will see. Now, what is this? This is basically a simulator software which will help you to configure computers and check the communication. You can, there are a whole bunch of devices which you can try out here. So, computer. So I have a computer here. I have another computer here. Okay. Now these two computers are not connected in any way. I'm going to connect it with a cable. And these two are connected now. Will I be able to communicate from this computer to this computer now? Yes? No? What do you think? Can these computers communicate each other now? This is very much similar to we connecting a computer to another computer in the, like, physically. It's exact same representation. Now, I mentioned about ping earlier, right? Let's try that, right? This gives you an option. Okay. Now, here's a command in Windows which will help you to check if there is an IP address. There is no IP address configured here. Let's check the second computer. There's no IP address configured here. So even if you physically connect two computers, it still won't be able to communicate each other unless it has an IP address configured to it. And once you configure it, this becomes a complete network. And this is a network. Even though it's just two computers, it's a small network. All right, let's configure an IP address now. Hopefully you're following along. Config interface fast Ethernet. This is where you need to configure the IP address if you are .1.1. The subnet mask automatically popped up because this is the default subnet mask. Now you can play around with it to change it, change the number of hosts, but this would work for our purpose. Okay, question time. What IP address should I put here to enable the communication? You may post it in the quiz question, Figma board, or in the chat channel. What IP address should I use in the second computer? Yep, there you go. 192.168.1.2. Okay, now we have an IP address, right? Okay. Okay, now I can check the IP address in this computer, and if you notice, the IP address is configured now. Now, To check the connectivity with the other computer, as I was saying, we can use ping 68.1.3. It's failing, right? Because I put the wrong IP address in the ping. If I stop that and change the IP address, you will see that it's working. We are getting a reply. I know it's a bit small. Can you guys see when I share the screen? Like the
No, actually, but if I'm zooming into my own screen, so then I can
yeah.
see it.
Okay, okay. Yeah, I don't know how I can zoom this, but if you're following along, that's best. All right. So that's how essentially you configure two computers to enable communication between each other. Now, let's try this. Let's try this. I'm going to change this to 168.1.1. Okay. Will I be able to connect to the other computer now?
Wait, what did you just do? Just a second ago?
Oh, yeah, sure. So I went to the config, I went to the fast Ethernet, I changed the IP address from 192 series to 172.
Oh, okay.
Came back to the terminal, checked if the IP address got configured, and yes, I see it's configured. Now, will I be able to still ping the other computer and get a response? Share screen. I think I did a entire screen share, but okay. Oh yeah, different network. You're right. I won't be able to reach the other computer because it's a different network. It won't work, right? Now, let's do something else. What will happen now?
That's the same
Okay,
IP, right?
just exactly. I use the same IP address, right? Now, it it didn't even work. So basically, when you do that in actual computer, you will see that IP address conflict. You will see a message. So the network won't allow you to configure the same IP address. Now, how this works is, remember the broadcast IP address, what I mentioned. Anytime when a computer gets an IP address, it sends out a broadcast that, hey, I have this IP address. This is where you can reach me. But then if another computer has the same IP address, it will respond back, hey, I too have the same address, you can't use it. So there would be a conflict. You have to change it. So that's that. Hopefully clear so far. Any questions?
Yeah, that makes sense. I think somebody's asking something in the chat about the first example.
Yeah, let me check. Different network might not
Oh,
work.
no, no, never mind. They removed it.
Okay, okay. All right, so that's that. Did we have anything else in our agenda? We spoke about probably a special IP address, dynamic and static IP address configuration. Now, what we did just now is configuring IP addresses manually. But imagine you are an administrator for a large company. There might be hundreds of computers. It's not practical to configure it manually. There could be errors too. That's where the IP address configuration is done automatically. What is done is basically there is a protocol called DHCP. Let me write that down. DHCP, Dynamic Host Control or Configuration Protocol. That basically once you configure DHCP with a block of IP address, it will automatically distribute IP addresses to any computer which is connected to the network. Now you need to ensure that the computer is in. So if you see IP address configuration, you will see there is DHCP and then there is static. If you choose DHCP, that means this computer will connect to that DHCP server and get that IP address. Clear? Any questions?
So who gives your IP address to you, like your service provider?
Uh, So when you take an internet connection, right, the ISP usually gives you a home router configured with a public IP address. All you get is one single public IP address. Now behind that router, you can have multiple devices which is connected to this router. Now the router will give private IP addresses to your devices, but whenever internet connection is required, these devices will reach out to the router. Router will send that to the internet and get that response back to the device in your network. So yes, the ISP will give an IP address to your router, but to your home devices, it's the router giving private IP addresses using DHCP. So that IP addresses are not given by ISP.
That makes sense. Yeah, I got that. Thank you.
Got it? Okay, cool. All right. Any other questions? A quick recap of Q4. Sure, absolutely. What was our Q4? Yeah, sure. So, so here the question was, why can't this computer communicate with this device in here? 0.4 to 1.7. Now in this network, it's a /24 network, right? Let's do everything with IP subnet calculator, so no confusion. Class B 172.168.0.0. Sorry, yeah, 0.0/24. Okay. The usable IP address is 0.1 to 0.254. So this device, this IP address is 0.1, it's 0.4. Both are part of this block and this can communicate, these two can communicate each other. That's fine. Great. Now, on the other side, this specific network is 1.0, again, /24, right? /24. It has a starting IP address of 1.1 and of end address of 1.254. Now 1.1 and 1.7 both falls into this block, hence both can communicate each other. Okay. Now there is another network which is between these two devices. It's 2.0/30. Okay. Now let's see 2.0 and slash value is 30. Now the usable IP address range is 2.1 to 2.2. Now, if you notice, one side it's 2.1, great, but the next side is 2.20, which is not part of this usable block. That means 2.1 won't be able to communicate with 2.20. That was the problem. Now we wanted to increase the range of usable IP so that 2.1 can communicate with 2.20. How we did that? We reduced the CIDR value. We used 27. That made it like 2.1 to 2.30. We have these two are part of the block now. So essentially, if I change the CIDR value to 27 in here, the communication will work fine. That was the fix what we applied. Does that answer? Okay, cool. I'm glad you got it now, Ankit. All right, with that, we are coming to an end. I do want to call out that this is just the first session in the series. We are planning a couple of more sessions in this series. Keep an eye on the GDSC UoL page and the Slack channel. You will see communication and also the social media pages. Thank you so much for attending the session. Once again, I'm sorry for the initial glitches we had. And thanks again. Anything else, Rita, Kylie, Sheila?
No, I just wanted to say thank you so much. It was a really good session, really interesting. And
Thank you. All right. Thank you so much.